Hi, everyone. Thank you so much. So I'm Timoni West, and actually, as of last week, I am not the director of XR research. I'm actually the director of XR product at Unity, which is very exciting. My team is the XR app team, and we have two goals. One is to figure out what we need to build today in order to help our community make great XR experiences. And second, think really thoughtfully about the medium itself and what we need to build in order to unlock anyone being able to create amazing things. How many people have heard of Unity before? Okay, great. I don't have to explain it very much. For those 3 people who didn't raise their hands, Unity is a 3D creation tool that allows you to build experiences that are robust and interactive by default without having to make your own rendering engine, physics engine, or animation tools. But let me just briefly, I'm not talking about this much today, but let me give you just a brief taste of what my team specifically works on. So we do some fun prototypes. In this case, it was an animation tool for VR where you could actually view it in augmented reality. We put Unity into virtual reality with Editor XR, which is our open source extension. You can download it on GitHub. But in this instance, we're actually rethinking how do you do hotkeys in virtual reality when you only have so many buttons. We also end up building some stuff that sounds crazy but actually works in the medium. For example, here we have 3 separate camera views, each of which is showing you a different part of your scene, different parts of it at different scales, and actually allowing you to not only move things in between the different camera views, but also outside of one particular camera view and into the real world, or not the real world, but your scale camera view, I guess. It gets pretty recursive really fast when you start working in virtual reality. We use virtual reality to prototype our AR creation tools as well. So in this case, we actually use Timoni to prototype what would become one of our companion apps for Magic Leap. And we extend things from virtual reality to augmented reality when it makes sense. So in this case, this is the same mini world that you saw in virtual reality, actually in camera in a Magic Leap. As we move objects around, you can see the person there moving the object around there. And of course, we move from prototyping and testing all the way to these polished, useful, everyday tools for new devices. So you see the rough stuff, and then you get to see the super polished work. Here, this is a brief snippet of one of our newest and most robust projects. It's called Project Mars, Mixed and Augmented Reality Systems. And it's a Unity extension and companion apps that not only allows you to test, design digital apps that can work in real spaces, but it allows you to quickly test and iterate as well. So you can see here above, we have a room that thinks it's a real room, that Unity thinks is a real room, and you can move around as if you were actually wearing an AR device or had a phone and test directly. So that's a bit of the work that we actually do day to day, which is incredibly fun. But today, I'm actually going to be thinking a bit further out about the types of realities that tools like this will help build. So here's the agenda for today. For this talk, by the way, I went with ambient computing, but you could call it spatial computing or ubiquitous computing or distributed computing, whatever rocks your boat. Really, what I'm trying to describe is this: computing devices that are alt-network, contextually aware, and your compute session is truly device agnostic. A lot of people would take this a step further and say that computers need to be aware and working with you, or you use them unconsciously. I wouldn't even go that far yet for reasons that I'll get into in a moment. This is also an incredibly biased talk. This is not comprehensive, but it's a huge topic, and I wanted to really delve into specific aspects that I thought would be most interesting to talk about with you today. So before we begin, I actually have a quote from one of my favorite authors, Ted Chiang. This is from his latest collection of short stories, Exhalation. How many of you have heard of Ted Chiang or read any of his works? A few of you? Okay. Let's go geek out about it over drinks later. Okay, so here's the quote. I did not make my slides big enough to read on here. So I'll turn around. I gotta take this out. Okay, so we don't normally think of it as such, but writing is a technology, which means that a literate person is someone whose thought processes are technologically mediated. We become cognitive cyborgs as soon as we become fluent readers, and the consequences of that are profound. So keep this in mind as we continue talking. I like this quote for two reasons. First, I think it's a reminder of how basic augmentation is for humans, how we do this constantly. We augment ourselves, we have ambient intelligence, we have whatever prosthetic knowledge, whatever you want to call it. And I think this also keeps us honest. I think there is a tendency to bucket things that are poorly designed outside the category of human-centered design, as if there was some like evil computer team working somewhere making all the bad design choices, and human design is what we're going to do right next time. So the reality is that humans are the ones who are responsible for any number of designs that other humans don't like, from architecture that feels too sterile, door handles that are too similar on both sides, rooms that are too empty, highway signs that are too confusing, dark patterns in web applications, and heck, frankly, just bad icon design. We need to own that this is also human design, and humans have been making these decisions every step of the way. Okay. So let's go into a brief history of ambient computing. As I mentioned, use whatever term you like. This is also, again, brief, extremely select, and extremely biased. We're going to start back in the World War II with Vannevar Bush. Has anyone heard of this guy, Vannevar Bush? Okay. Vannevar Bush, born in 1890, died in 1974, went to Tufts, got a doctorate from MIT in, I think, electrical engineering or something like that. Founded Raytheon, which is one of the largest government contractors in the United States to this day. Became VP and Dean of the School of Engineering back at MIT. Became the president of the Carnegie Institute of Washington, so basically the first scientific advisor to the American president during the wartime era. Chairman of the National Advisory Committee for Aeronautics, chaired the U.S. Office of Scientific Research and Development, helped start the Manhattan Project, helped push radar forward. Post-war, he started the American National Science Foundation in America. There you go, that's this guy. He was really seminal to very early and often classified work for computer innovation in America specifically. In 1945, after the war, he posts a seminal essay in The Atlantic, one that I would argue is one of the most singularly influential essays in human-computer interaction. And it's called As We May Think. Has anyone read this essay? Okay, a few of you. I highly encourage everyone to read this essay at some point. So remember, at this point in 1945, computers had made some truly significant strides, in large part due to military funding that he had secured. And he had been working in this field since 1918, which is much earlier than most people think. Albeit it was largely under sort of this classified wartime era technology, which I think is why people don't think about it as being sort of the hotbed of computer advances. This essay was articulation of that point in his life's work. What is the good of the technology that he had chosen to build, and what was the point? And this is what he said. Science has provided the swiftest communication between individuals. It has provided a record of ideas, enabled man to manipulate and make extracts from that record, so knowledge evolves and endures throughout the life of a race rather than that of an individual. The point is shared knowledge across not only one lifetime, but many lifetimes. However, there is a rub, and that is this. If records are to be useful, they have to be consulted. You have to think about it, you have to know where to find it, you have to remind yourself that you have this information and that you can reference it later. So he came up with a solution. He came up with a device that he decided to call a MEMX. A MEMX is a device that basically records everything about your knowledge journey. Think about if Wikipedia had two-way links, for example, has all the books, records, and communications, and you could share it. And one could argue that this is at least the very first public description of computers as human augmentation devices. In fact, Norbert Wiener, do folks know Norbert Wiener? Cybernetics? Okay, a few of you. All right, he specifically referenced Ford and cybernetics in the chapter on information, language, and society, specifically through the lens of a solution to the larger problem, which we still grapple with today, of information overload. Here's some key aspects of the MEMX. The idea was that human brains work by association, not by artificial indexes. This is true. The MEMX provides a historical trail of how you got from one idea to another, and most importantly, the trails are not only visible to you, but you can share them with others. So did this actually happen, the MEMX? Well, no, we never built it. Actually, I know one person who built one for fun, Trevor Flowers, and I think he still has it. But if you're familiar again with Ted Nelson's two-way hyperlinks, this might sound familiar. And of course, Doug Engelbart's work at ARC was directly impacted by this essay, and I'll talk about that in a bit. And as were many others. And every time I reread this essay, I'm inspired. Again, I would encourage you to check it out. So one key thing to note here is the humility with which Bush describes his concepts. He's not presenting this as a novel idea. He's just presenting it as a mimicking of how the human brain actually works. As he mentions here, the human mind does not work the way that computers work. It operates by association. And that's some solid human-centered design thinking right there. Fun fact, in the same essay, Bush also talks about how people are going to take a lot of photographs once the technology is cheap and ubiquitous enough. Yeah, he was right about that one. Okay, so enough about Bush and the mimics. Next up, in the post-war, but still plenty of military funding boom in America, we have JRC Licklider. So the internet tells me that this is a photo of Joseph Carl Robnett Licklider, or JRC Licklider, the first director of the Information Processing Techniques Office at the Pentagon's ARPA, but I'm not entirely convinced that it isn't just Michael Caine, because it looks like Michael Caine, right? I don't know, I just Googled for him. It's Michael Caine, right? Is this Michael Caine? Okay. In any case, the real Licklider came up with the term intergalactic computer network, and it's a real fucking miss that we never went with that instead of internet, but whatever. Anyway, it was the intergalactic computer network inspired ARPANET. And unlike the mimics, we all know how that went really, really well. Now we have the internet. Okay, so Licklider had this to say about human brains and computers. Men are noisy, narrow-banded devices, but their nervous system have many parallel and simultaneously active channels. Relative to men, computing machines are very fast, but they are constrained to perform on only one or a few elementary options at a time. Good point. With this view, it's no surprise that he chose to tackle the very problem of how to get computers to have more active channels, behaving, again, more like humans. Also worth noting is that this was published in 1960, which means these ideas were kicking around long before then. I do think, I mentioned this briefly earlier, that all of the 1950s is kind of an interesting silent innovation period for computers in which perhaps all of the groundwork is laid out for what we're even doing today, but people barely remember or even start to think about this until the 70s. And again, I mentioned a lot of this information was classified for a long time, and I think that's why there's so much silence around computer innovation in the 50s. In any case, Licklider's goal is very similar to Ford's in that he wanted to have a true partnership between computers and humans. As he says here, the resulting partnership will think as no human brain has ever thought and process data in a way not approached by the machines that we know today. And this concept of this human thinking differently and this computer being able to augment that human thought is echoed in the later work of Lincoln Labs as well, which did a lot of things, but most notably Ivan Sutherland's Sketchpad. Have people seen Sketchpad? No? Okay. Sketchpad was the first graphical user interface where you could actually draw on a screen. Came out in 1962. And it's referred to as a graphical language rather than a visual language or a spoken word language, which I think is interesting. The idea was that just drawing on a screen was as much of a language to a computer as typing. This is a quote from Stephen Coons, who is the advisor on the Sketchpad project. And this is him describing it. And he says specifically here, the computer and the man will be in cooperation, in the fullest cooperation in this work. The idea is that a designer has a problem, he is solving a problem, but he doesn't know what his problem is. I think this is interesting as well. This will come in full force in a minute. It sounds a little abstract here. But there is a concept that computers can not only help us solve the problems that they have, but they can intuit what the problem is that we have. When it comes to ambient computers, so day-to-day life, this is essential to having them work in a way that is effective. They need to have that context. But yeah, this was something that was kind of a general theme in the 60s, was that we'd built these machines that we knew were quite powerful, but they didn't want to just have their questions answered. They didn't want just a big calculator. They wanted to know what the right question was to ask. Back to Licklider. He says, men will set the goals and supply the motivations, of course, at least in the early years. But the assumption was that at some point, computers would start to take on more and more information and be able to make better decisions on their own. Ha, ha, ha. So he thought, it's a little depressing reading this. Everyone just says, in 20 years or in 5 years, computers will know everything about the world. Yeah, no, unfortunately not. The assumption was, though, that if we did computers right, we'd get to a point where they could intuit what we wanted. Truthfully, obviously, we are not there yet, and that is the biggest barrier to having true ambient distributed spatial computing, whatever you want to call it. On the bright side, certainly computers have been great at facilitating human-to-human communications with computers as sort of the middle point. Here, Linklater actually name-checked Doug Engelbart in this particular paper. Because apparently he was the first one to have a networked, what do you call it? Like Zoom, teleconference. He was the first one to ever host a teleconference. All right, how many people have heard of Doug Engelbart before? A few more, okay. Folks, I'm going to make this essay available online. Go Google every single person that I just mentioned here. All right, Engelbart. Augmented Research Center, MLS, mother of all demos, did not invent the mouse, although a lot of people give him credit for inventing the mouse. Doug Engelbart was a big fan of Ford's. He read that essay, as we may think, and he deeply took on the problem of how humans learn iteratively and how that can apply to human-computer interaction in many ways. The work that he did at ARC, the Augmented Research Center, became Xerox PARC later on. Many of the people who worked there with him went on to PARC. The PARC folks went on to Apple. The GUI was born. The mouse took off, et cetera, et cetera. So we're talking about here like a deep sort of genealogy of how we work with the computers that we work with today, going all the way back to Ford. So Engelbart said, the human mind neither learns by acts nor large steps, but step by step, organized or structured. Again, the sense of iterativeness, the sense of association, this is how humans learn. This is the continuing theme that all of these folks working in the field thought of as great problems. Quick side note here, we are focused on the tech around human-computer actions mostly, but this step-by-step process is also partly why humans tend to feel comfortable around tech exactly when it stops feeling so magical. I've always wondered why we insist on calling the tiny little pocket computers that we carry around all the time phones. But then it occurred to me that if we started calling them magical tiny pocket computers in 2004, maybe we never would have bought them. Maybe we needed to call them smartphones in order for people to feel like it was something they were comfortable with. And that's why they took off. So I'm not going to go over Doug too much. I've actually gone over his work a lot in previous talks, specifically around human-computer interaction, but not too many people raised their hands, so I'd highly encourage that you go watch at least part of the video of the mother of all demos. He describes an online system, he has teleconferencing, he has version control, object-oriented programming. A lot of the stuff that we now take for granted, he was demoing it as a cohesive package back in 1968. Instead, I'm going to talk a little bit more about one of his mentees, Mark Weiser. Ring a bell? Anyone know Mark Weiser? Okay, you know everybody. It's great. All right, okay, so Mark Weiser is actually the guy who coined the term ubiquitous computing around 1998 during his tenure as the chief scientist at PARC. And like many other people that I've mentioned here, he too wrote a seminal essay that I will quote too much and read the screen and slides off of directly. This one is called The Computer for the 21st Century. Side note, I guess if you want to get quoted a lot, write a seminal essay. That seems to be the way to get into the annals of time. Okay, so he said here, the most profound technologies are those that disappear. They weave themselves into the fabric of our everyday life. Again, tiny pocket magical computers doesn't weave itself into everyday life the way just calling it a phone does. Consider writing, perhaps the first information technology. It freed information from the limits of individual memory. Again, this relates to what Ford said too, around the idea that we can take the information that we have now that is written down and referenceable, rememberable, across not just an individual's lifetime, but across an entire race or species. One key difference from what he thought of versus what a lot of the prior folks had been considering, he also wanted to break out of the concept of an individual computing device, a piece of hardware, as a discrete unit in and of itself that a person would interact with. And this is really where it gets into ubiquitous computing. He really kind of wanted to demolish the whole concept of, I need to have a computer and that computer takes up my attention. Instead, he wanted to fade it into the background. So I would grab one thing when I needed it and something else when I needed that. So this is him right here really making the case for distributed computing, specifically, where you have a compute session that exists outside of any given device you may choose to use at any moment. He says it fades into the background, which I understand from context, but I think it can be really framed as a move for computers from conscious prefrontal style attention from the user to muscle memory. So dependable tool-like interactions where we're moving into computers really as tools as opposed to an input system in and of themselves. I think we have this a little bit today. Actually, I think about this a lot when people are sort of randomly picking up a phone just to check something and putting it down again. That seems a little high twitch, but it certainly is using the computer more as a tool than something that you consciously are trying to use. And again, here he's making the point, I've already went over this a little bit, that hardware itself should have no individual identity or performance. I actually had a friend give me a great example of this, and I'm going to steal it and use it in an example. So right now you have a forward-facing camera on your computer, and you can in theory, you can use your face to open it, depending on which operating system you have. But there's no reason why, if our compute session is running in the cloud, that we wouldn't have anything actually running locally on the device, but just instead render down frames over the network when the network is faster. So that if I turn the computer to you, instead of showing the frames from my computer session, it now shows you the frames from your computer session. In the instant from the frame refresh, it goes from being my computer to your computer and back. And then that then begs the question, what does the computer look like when it's both our computers, when it can see both of our faces? And it's not encapsulated in this quote because this talk is already full of quotes. This is the most quote-y talk I've ever done. But I really wanted to get the historical record out there. But the key to this concept is the idea that contextually aware apps and devices, the apps need to know where you are, where they are, and what they mean to you, and what they might mean to someone else in the room, in order for these systems to work as described. There's also some interesting ethical considerations here, of course, around privacy and around autonomy, especially of the individual. In theory, and also just in terms of ecology. Okay, so in theory, I agree with this concept that devices should be sort of removed from your interaction with the computer, and there should just be a ton of devices laying around that anyone can pick up and use. That sounds great. It sounds like utopia, right? It also sounds really democratic, and that people who couldn't normally afford these devices could just get access to them. But in reality, Apple has kind of achieved this right now with the iPhone. If I lose an iPhone, I can replace the entire thing within about 10 minutes. But the second order consequences are pretty severe, because this device still just belongs to me. It is so easy to simply throw away or lose a physical object and replace it because the physical object is not that important anymore. So we've got one side of it, but the other side of it, the second order consequence, is not one that he could have considered at that time, because it never occurred to him that devices would be this cheap or this ubiquitous. iPhones can still really only be owned by one person. This is for security reasons, this is for privacy reasons, and yet, at the end of the day, if they could be owned by more than one person, we could start to avoid problems like this. All right, getting back to Weiser, I just have one final point. He was pretty humble about the idea that what he was describing was not going to fundamentally change anything about the world. Instead, what he said is that it will just make everything faster and easier to do. And again, this is kind of the sentiment of the Augmentation Research Center as well, that they weren't going to try to allow humans to become something other necessarily, but simply they were going to allow humans' knowledge to exist past, again, an individual's life cycle to more and more generations. It's also worth noting By this point, Weiser had grokked a lot of what Ford, Licklider, Coons, Sutherland, and Engelbart wanted out of computers, but he doesn't talk as much about the computer as a partner, as computers coming up with the questions themselves. And I'm not sure if this was just the era that seemed like enough had been said on that subject, or I don't know, maybe he was just cynical about the possibilities of what could be done, or maybe he just thought it was beside the point of what a computer could do. Okay, so this is actually, I'm stopping at 1998, or 1988, which means there's a lot of history since then. But I'm stopping it here for a couple of reasons. First, once ubiquitous computing was named, and it had a lot of documentation, prototypes, and examples behind it, it really took off as a general guiding principle that has continued ever since. You can see the thread to this day in various ways. Computer tablets, network digital whiteboards, Zoom meeting rooms, Find My Phone, all of these have precedence in the work that Weiser's team did at Park, and of course, the earlier work that I mentioned as well. But we don't have it yet. We don't have an entire sensible system in place in 2020. And we may never have, frankly. So what do we have at this moment? Let's move on. Current advances in the tech: sensors, operating systems, networking, and machine learning. This is, I think, going to sound a little boring, but again, that's the point. Once technology starts to become ubiquitous, once it starts to become dependable, it is no longer all that interesting. So I'm calling a lot of this stuff out because it's kind of obvious. Networked accounts allow for maintaining state across almost all devices. Essentially, today, you can't have a compute system that isn't dependent on one specific device. When I pause Spotify on my phone, I can start to play it again on my laptop, and it doesn't seem magical at all. And yet, that is part of ubiquitous computing's mandate. Seamless synchronization of files is now the norm, and that's disappearing tech, if you will. I didn't even have to think about whether or not my presentation was going to be backed up two places, both iCloud and Dropbox. Been paying for Dropbox since like 2008. And APIs, IoT, if this and that, countless integrations. Now they're the norm. Fun fact, I didn't know this. I just thought I'd throw this in as a tidbit. The first web API was Salesforce back in 2000. I did not know Salesforce existed in 2000. And I didn't mention this on this board, but it is also worth calling out that there are new standards boards specifically around device-device interaction, or actually a lot of FANG companies are now joining IoT, home, sensor, and device-specific boards, which is very exciting. In terms of operating systems, we have real but more demonstration-y, and then I have an example that is just a concept. So real, we have Google Fuchsia, which is modular, capability-based operating system. It's designed to work across various devices in the Google family. Dynamic Land. Has anyone been to Dynamic Land? I kind of wish I had included it in a picture. Okay, if you go to Oakland, I highly recommend that you go visit Dynamic Land, which is a giant building that is running an operating system and uses projectors and computer vision to let you program with paper and actually have your apps run entirely in the space. And actually that's run in part by Brett Victor, who came out of the HARC lab that was inspired by the Park lab that was inspired by the ARC lab. So it goes all the way back down. Specifically, and I disagree with Brett about this, but it's okay. He's much smarter than I am. It's designed to have people work together with real objects in the real world. My team went to go visit, and we instantly wanted the whole thing in augmented reality, and he was not a fan of that. And then finally, Mercury OS. Please Google this. It's very, very beautiful. Actually, I think I do have an example of what that looks like here. Very pretty. It reimagines the operating system as extrapolating out the data layer from what task you want to do. So there are no real applications. And instead you say, I want to plan my trip to Amsterdam, right? I'm going to Amsterdam. So that would include my calendar. That would include, maybe like Yelp or something. It would include maps. It would include my airplane itinerary. So moving away from the concept of having a bunch of discrete open applications and instead to a task-based system. I think this slide is the slide I was supposed to have up when I was talking about all of this, so I'll just let you look at it quickly. Yep, okay. All right. And again, here's that example of the Mercury OS, which is trying to move away from from the concept of apps into a flow. I'm currently in the flow where I'm listening to music and talking to my friends. New devices. A lot of this isn't new. Again, a lot of this is going to seem kind of boring, and yet, again, it certainly falls under the umbrella of ubiquitous computing. Augmented reality, I love working in AR for many reasons, but one of the reasons I like it is it really forces you to think of concurrently running 3D applications in the same space. There is no world where I have a spatial OS and I don't want Spotify sitting alongside my email, sitting alongside whatever else it is I'm doing. Right now, that is very difficult to do in considering the current technology. Mobile OSs are pretty like I'm in one app at one time, but AR kind of forces you to bring it back out again. Smart speakers, embedded assistants are, truly spatially agnostic computing inputs. And by spatially agnostic, I mean I don't have to be next to Alexa or Siri in order to interact with them. I can be anywhere in my home. As long as they can hear me, they can not do what I tell them to do, And finally, wearable computers. I also love them because they sort of force this idea that they are extensions of the other computers. I don't want to have to log in on my watch on Spotify. It better just fucking work, right? I'm not going to type in tiny little letters on this tiny little device. It's great. Brief segue into augmented reality just for a moment. Humans, we talked about this earlier, even writing, even literacy is a form of human augmentation. But humans augment everything constantly. Look at this water bottle. It has a label on it. It tells me what it is. What is this if not a type of augmentation of an object so that it has contextual information in space, right? What is the difference between a wayfinding app on Google Maps and the actual street signs that we put all over the world? They're both labels that are in space that weren't there normally that gives us some sort of contextual information in place. Then one advantage, though, to this specific medium, when you say what is AR good for or what is VR good for, is that they don't have to follow the laws of physics, and they can appear and disappear in a way that real-world objects simply cannot. To me, that is the true value and strength of the digital medium itself. Mei-Li Ho mentioned this as well. Ephemerality isn't necessarily a benefit of a digital medium. Sometimes it can be really negative. But on the flip side, things can literally disappear or be erased to take up little to no physical space and then reappear again. Again, I think this is a great encapsulation of the strength of the medium. This relates to one of my favorite types of UI, which I call transitory UI. You can call it whatever you want, which is just UI that can appear and disappear as needed. It doesn't have to be an AR display necessarily. It can be a projector. Heck, even now, this is going to go away in a little bit because it's not important anymore. Ephemeral, transient UI that appears when needed and goes away when it's not needed. This also falls very in line with the calm design culture that many folks that are referenced here also write about. Have folks heard of calm design? There's been some recent books about it. It's sort of an extension of ubiquitous computing and ambient computing, where we're trying to make technology that soothes rather than forces attention. Good fucking luck. That's very hard. All right, one more. This is from, I don't even know how to say his last name. Matsuchuk? Andy Matsuchuk and Michael Nielsen. They write a lot about tools with that. I think this is, I don't want to read this. You can all just read this. But effectively, again, here, the focus here is that the medium itself expands the possibilities for human thought. Okay, significant challenges. I know, this is so text-heavy, folks. I apologize a little bit, but I really kind of did this on purpose, too, again, because I also wanted to show that although ubiquitous computing and ambient computing sound like terms that we're thinking about today, they have been thought of for a very long time, and yet we don't have them yet. So why don't we have them yet, I think, is kind of the big question I'd like you to leave with. So back, Mark Weiser, Computing for the 21st Century, he says, he's kind of dissing virtual reality here. He says you're going into the world, it's a digital world. It's not like the real world at all. And that can be a negative. I suppose so. This type of all-encompassing environment does have consequences. You are profoundly affected by that which surrounds you. This is actually a quote from the American scholar by William Derweiswich. Not good at last names at all. This is actually just an essay on thought. He was actually a general in the army who wrote a really beautiful essay on how to be affected by or deliberately think about how you're affected by other humans. And he says, when you expose yourselves to these things, and apparently in a constant way, you are continuously bombarding yourself with a stream of other people's thought. This is actually one of the biggest responsibilities that designers have today in the field, because every decision they make is something that is reflected in what other people use or think that they can possibly do. Working at Unity, I know that every drop-down label that we have profoundly affects what people think they can do with that drop-down and how they're going to reference and make a mental model of it later. There is, of course, a lot of discussion around this, especially when it comes to ambient computing in the future and the responsibilities that we have. This is actually from a commission that was done, a workshop in 2004 from the European Commission and the NSF. And they asked these very thoughtful questions. How much should we or the infrastructure remember about users? What do we try to predict about the user, and when do we let them choose? And how do we convey the system boundaries to the user? All of which are profound thoughts. There's another challenge, though. This is the kind of challenge that actually keeps me up at night. It's the assumption that we have access to the right data at all times and that it will be standardized. I see this when it comes to ambient computing, ubiquitous computing, even just augmented reality. I see this assumption all the time. Again, Weiser says, obtaining information will be trivial. The computer environment knows the suit you looked at, can bring it back up again, and if it didn't interest you then. We don't have this today. I mean, not really. How many times have you bought something online and had that ad follow you around for the next week? You know what I'm talking about? We don't even close the loop on advertising, the primary way the internet runs today. This is from this year. The technology will be able to talk to you, take the initiative, handling some tasks automatically and alerting you only when necessary. If you've ever worked on notification systems, you know this is a motherfucker. This is one of the biggest challenges. When do we bother people? When do they actually want to know things? That context awareness, that's really hard to get right. This is actually one of my favorite articles I've read recently. It's from Fortune magazine in 1994, predicting the rise of online retail as rightly but as wrongly as they possibly could. They were right about everything, but they said it in the wrongest possible way. So they were saying systems could automatically comparison shop from us. Again, this is an article from 1994. The last one was from 2020. We're still saying that in the future this is going to happen, okay? So the question is, how are we actually going to make it happen in the next 20 years? Again, it's saying computers can, find data from the network and gain information. Holistically, this is not the case, right? Again, same article. Here they said that Time Warner won't permit automated comparison shopping. Well, Time Warner did not predict Amazon, which actually did that. Moving on to other misconceptions. I think the most common that's applicable to ambient computing is the assumption that we can make correct inferences about user desire without the users telling us. Context is extremely hard to describe. It's not only hard to intuit, it is not only hard to detail, it is not only hard to code against, it is hard for humans themselves to even describe to themselves or each other. User awareness of intent varies both tremendously in terms of just literally everything. So for example, you might be in the right place at the right time, but you might be busy. You might not look in the right direction. You might have forgotten something. You might have been distracted or partially disabled. Maybe you stubbed your toe and then you missed the information, or you really don't need that notification right now. The computer has no way of knowing these things right now. Also, there is a sort of variability of user consciousness around their own intent. I see this all the time. I've had this on every single slide deck since I started working at Unity, but I'm going to reiterate it here. We're going to have users tell us things that they would never normally articulate or think about. I have an example. It's a fun example of something that we don't usually account for in today's software design. Let's do a little bit experiment. You might have seen this going around the internet lately. Okay. I want everyone to close their eyes. Don't worry, you just have to think. So close your eyes. and visualize a ball on a table. Okay, got it? Now imagine someone walks up to the table and gives the ball a push. What happens to the ball? Okay, you can open your eyes. Okay, now you don't have to say this aloud, but I want you to answer these questions. Actually, let's do this. Let's raise your hand. What color was the ball? Who knows? Not everyone. Okay. What gender was the person that pushed the ball? What did they look like? What size is the ball? And what about the table? What size was it? What shape? Color? And now the important question, how much did you know and how much did you retroactively think of when I asked you those questions? You saw the hands falling up and down based on what it was that I was asking. If you could answer all of them, great. If you could answer none of them, actually also great. If you not only couldn't answer them, but these questions kind of took you by surprise because you never really imagined a ball, you probably have this, which is a new thing that I just learned about myself, aphasia, which just means that you don't see things pictorially in your mind. It's not necessarily a bad thing. It's not necessarily even a handicap. In fact, we've only recently begun to notice that this exists. There are different levels of fidelities in how humans visualize things. Okay, so we're not starting to design for it. We haven't even really thought about it. The first big study came out in 2015. It's 5 years ago. And yet this is a tremendous amount of contextual information about when you say ball, what is someone else actually thinking about? This is another visualization that was going around recently. Which apple do you see from 1 to 5? I have a friend who said she not only saw 1, but she could smell the apple and taste the apple, and it was a specific apple. She's like a -7 on the other end. Okay, but again, this is something new, and this is probably a huge part of what we should think about when we think about ambient computing and contextual computing for humans. And of course, everything else. Personalization. When I have a iPhone, what color do I want my watch to be? What size? Did anyone go to Beryl Chung's talk earlier? The one on human design? A couple of you? Okay. She mentioned specifically that Mattel shut down a personal assistant for children because it seemed creepy, children, privacy, how are they going to be raised? But it allowed you to have a setting about whether or not your child had to say please. So that's another question. How polite do you want your children to be? How many times do you think about this? How many times have people talked about this? They don't. Again, it goes back to what I was talking about earlier. We need to teach people things. I'm going to shuffle forward a little bit. Oh yeah, this slide. We assume computers understand. They don't. They do not. We're teaching them a little bit, but it's not really understanding. I'm going to fast forward because I'm running out of time. But again, we're going to need to tell computers things that we never articulate about. Number 5, implications. This is the important part. This theme has been kind of run through this whole talk, but I think it's very important. Again, I had this quote on before. Focus on this. We'll think as no human brain has ever thought. That is an interesting notion that we can really push forward, how we think based on computers. And the reality is we have this all the time. We have changed how we communicate with others based on computers themselves. Here too, the computer will be able to write once to indelible memory and then read back indefinitely, but the computer will not be able to erase indelible memory. This is Licklider from Man and Human Computer Symbiosis. The computer will be able to refer to it repeatedly, but not to change it. So what does that mean for humans as we interact with computers? I'm going to go back to Ted Chiang. This is a short story about a man who lives in the future where everything is recorded, and he realizes that his own memory has failed him. And he knows this because his memory has been recorded. So he's reflecting on what this means for humans. Before a culture adapts the use of writing, when its knowledge is transmitted exclusively through oral means, it can be very easily revise its history. It's not intentional, but it is inevitable. They adapt the material to their audiences and adjust the past to suit the needs of the present. This is where we are now. The idea accounts for the past should not change is a product of literate cultures. The histories in oral cultures don't need to be accurate so much as they need to validate the community's understanding itself. So in an oral culture, it doesn't matter if the history changes. That is not the point of it, to be precise. But right now, internally, each human is its own private oral culture. We have not internally become literate because we don't remember things correctly. We rewrite our past to suit our needs and support the story. With our memories, we are all guilty of an interpretation of our personal histories, seeing over our former selves as steps towards the glorious present selves, but that era is coming to the end. We now have the first of a new generation of memory prostheses, and as these products gain adoption, we'll be replacing our own internal oral histories with perfect digital archives. We will have a record of what we actually did instead of the stories that we tell ourselves. Within our minds, each of us will be transformed from an oral culture to a literate culture. I think that is profoundly interesting, especially as we move forward, building out ambient systems, and as we interact with the computers, hundreds of computers in this very room. What does that mean for how humans will think of themselves and how we will think over time? All right, that's all for me. Thank you.